Move to question number 14. So in this question, a beautiful circuit diagram is given in which a battery, a resistor, two emitters, and a capacitor is given, correct? And a student built the circuit shown. We'll come to the question. The capacitor was initially uncharged. That is also a key word. That means there is no charge on the capacitor. That means the complete current or complete charge flow is happening from the battery, 5-volt battery. Okay. She closed the switch. She closed the switch now and plotted the graph. And the current reading on ammeter A1 against time. So that is the plot she made. Okay, so what is the first question related with this? The first question related with this is determine whether the initial value of the current on the graph is consistent with the values stated on the circuit diagram. Okay, so what is the initial current from the graph? Please help me to figure it out. It is somewhat nearer to halfway between 0.1 and 0.2. Please see, the current is given in milliamperes, right? So nearly 0.15 milliampere is the initial current through the ammeter A1. Any objections, my dear students? No, right? So nearly 0.15. This is the current, the initial current we obtained from the graph. So this we need to cross-check, or we need to check whether this is consistent with the circuit value. So initially, when the circuit is closed, when switch is closed, definitely the current will start flowing through this resistor, correct? And gradually after some time, initially maximum current flow is there, and now it is connected with a capacitor. We know the concept. That means after some time, what happens to the current flow? The current flow decreases. Current flow decreases as the capacitor is charging. We know the concept. So that means maximum current will be there during the initial stage. So according to Ohm's law, what is Ohm's law? The potential across the resistor we can calculate by the equation V is equal to I into R. V is equal to I into R. Product of current and resistance is the potential drop across the resistor. So initial current flow through the resistor could be calculated by I is equal to V over R. Am I right? I is equal to V over R. So what is V? Potential through this is 5 volt divided by resistance 33 kilo ohm means 33 into 10 to the power of 3 ohm. So take your calculator and find the answer for this. 5 divided by 33,000. That will give us 0.0001515 recall. So that means nearly 0.15 into 10 to the power of minus 3 ampere. So that means it is 0.15 milliampere. What that indicates, or what that shows? It shows that since the calculated value from the circuit and obtained value from the graph are nearly same, this is consistent. Because we need to check whether this is consistent or not. Yes, we checked and we obtained the value, and we cross-checked, and the answer is what? It is consistent. Clear, my dear students? So how many marks? It's just a 2-mark question. So that's it. Now, explain how the current on ammeter A2 would vary over the same time interval. So this is actually the current variation for ammeter A1. And you can see this is an exponential decay, correct? The current is actually decreasing exponentially as time proceeds or progresses. Now what happens to the ammeter A2? You can see that this ammeter A1 and ammeter A2 both are in series combination. Back-to-back arrangement, correct? A1 and A2 are actually arranged in back-to-back position. So therefore, we can say they are in series combination, correct? So if anything is series, the current is also same. Okay. So what is the speciality of series combination? If it is series, suppose these are two resistors. I'm just giving an idea. Okay. This is not at all required for your exam purpose. This is for your understanding. I am explaining. Okay. So if we have two resistance R1 and R2, and if this is potential V, definitely the current will start flowing, correct? The same current I is passing through R1 and R2. The same scenario works for ammeter. So if we have two ammeters with us, this is ammeter A1, this is ammeter A2, then the same current flows through ammeter A1 and A2 because current is constant in series combination. So how will you answer this question, my dear students? What is the answer for this? Since A1 and A2 are the current vary with the time in the same way as on ammeter A1. That's it. Clear? That is the answer for this question. Okay, well, now to the C question. Proceed to C question. Determine the capacitance of the capacitor. So what is the value of the capacitance of the capacitor? We have the graph with us, right? We have the graph. So using this graph, you can obtain the value. Yes, in chapter number 6, you already learned any exponential graph we can write in the linear form. So what is the general equation for this thing? The exponential decay of the current. Exponential decay of the current. I is equal to I0 e to the power of minus T over RC. Correct? Minus T over RC. This is the equation for the general exponential decay of the current through what? The capacitor. So if you are taking logarithm on both sides, we know the formula. I'm not writing the I'm just writing the derived formula. I'm not going to the derivation. So len I is equal to len I0 minus T by RC. Minus T by RC. So this is in the form of a straight line y is equal to mx plus c. So what is the moral of the story? That means if I'm plotting, or if we are plotting the graph of len I versus the time graph, this will be what kind of graph we will get? It is a straight line with a negative gradient. Straight line with a negative gradient. Okay, anyway, how this will help us to find the capacitance? How we will get the value of capacitance? Randomly, you can take two values from the graph. Okay, randomly you can take two values from the graph. That will help us to find the value of C, because the resistance of this circuit is already known for us. What is the value of R? 33 kilo ohm. That means 33 into 10 to the power of 3 ohm. Then tell me, sorry, two values from the graph. So for example, okay, so this is the graph, correct? This is the exponential graph, and straight away you can take this value. When, what is the value of the t? This is 10, so that means it is 3 seconds. So when time is equal to 3 seconds, the current through the circuit is equal to 0.1 milliampere. Correct? So we can substitute this. And what is the value of the initial current? Initial current is 0.15 milliampere from this question, because that was the A part. When we will get I0? I0 is happening when time is equal to 0. And the current is equal to 0.1 milliampere and time is equal to 3 seconds. Using this, can you please help me to figure it out, the value of C? You can obtain easily. How? Ln 0.1 to 10 to the power of minus 3 is equal to ln 0.15 into 10 to the power of minus 3, because milliampere will convert to ampere, minus after what? How many seconds? Exactly happening after 3 seconds. Time is 3, divided by 33 into 10 to the power of 3 into capacitance. So please plug the values. We have already plugged, and you may see the subject, please. Now ball is in your court. I'm giving you some time to calculate. So what is the value of C? How will you make C the subject? So C will be equal to ln 0.15 into 10 to the power of minus 3 minus ln of 0.1 into 10 to the power of minus 3. Calculate it. Okay, other way around. I will straight away write that answer. So C is equal to 3 divided by ln of 0.1 into 10 raised to minus 3 minus ln of this is 0.15 into ln of 0.1 into 10 raised to minus 3, all multiplied with the resistance 33 into 10 raised to 3. So if you're plugging this, if you're calculating this value, you will get nearly 2.2 into 10 raised to minus 4 farad. 2.2 into 10 raised to minus 4 farad. Okay, you can just cross check it. 2.2 into 10 raised to minus 4 farad. Yes, so that is the answer for this question. Now determine the charge stored on the capacitor after 30 seconds. After 30 seconds. What is the equation for charge? General equation, exponential equation is Q is equal to Q0 into e to the power of is equal to Q is equal to Q0 into e to the power of T by RC. Because storing of the capacitor is a positive exponential graph. So what will be the charge stored on the capacitor? Q0 into e to the power of T by RC. So plug the values. So here they are saying what? Determine the charge stored on the capacitor after 30 seconds. Correct? I already explained. We can use this equation Q is equal to Q0 into e raised to T by RC, or else you can use the values from the graph itself. Okay, so here after 30 seconds, literally this current through the circuit is dying. You can see here, right? After 30 seconds it becomes zero. The current flow through them is equal to zero. That means maximum charge is stored on the capacitor. That is the reason why the current flow literally becomes zero. Okay, so even we can use another formula, because directly we'll get the value. The charge stored on the capacitor, Q is equal to C into V. Maximum charge stored is equal to maximum charge stored on the capacitor is capacitance. We already got 2.2 into 10 raised to minus 3. Since we know that it is the point at which the maximum charge stored, because after 30 seconds maximum charge is stored. So 2.2 into 10 raised to minus 3 into the potential between them is 5. So if you're substituting, we will get 1.1 multiplied by 10. This is 2.2 in 10 raised to minus 4. Okay, so my bad. The capacitance is 2.2 in 10 raised to minus 4. Then multiplied with the 5, we will get what? 1.1 into 10 raised to minus 3 coulomb. That is a maximum charge stored on the capacitor. Any questions? Don't get confused. Okay, Q is equal to C into V, we can apply directly, because Q is equal to Q0 and e raised to T by RC, we can apply. But since it is a 2-mark question, straight away you can apply the formula and find it. 1.1 in 10 raised to minus 3 coulomb. Then determine the maximum energy stored in the capacitor. What is equation for maximum energy? We already know maximum charge stored and as well as capacitance. So the energy stored we can calculate by the equation half CV square. So half into capacitance 2.2 in 10 raised to minus 4 multiplied by voltage, that is 5 square. So nearly you will get what? 2.8 into 10 to the power of minus 3 joule. So this is the energy stored on this capacitor. Even you can use this formula as well. W is equal to QV by 2, or you can use Q square by 2C. Whatever be the equation we are using, because here if you are using these two formulas, the charge we should substitute is this. Then only we will get the maximum energy stored, because maximum energy depend upon maximum charge stored on the capacitor. Clear? So that is the idea about this.